Hi, in this video we're going to learn about polynomial function. Well, what is a polynomial function? As you can see in here, we have one of the polynomials function, and we know that this polynomial function has 4 terms, and the thing that separates the terms from each other is either a plus or a minus sign. So, in this example, we have 4 terms. And if they ask us what is the leading coefficient, in this example it would be -4. The reason is it has the highest degree. And what's a degree? Degree is a power. As you can see in here, we have degree of 2, and we have the degree of 4, and in this we have a degree of 1. So the highest degree is 4, and the leading coefficient would be -4. So we have 3x cube plus 4x -2 plus 3, and if we had a power of a half, or the symbol, or let's say the as you can see, x is squared, or even when we have a power of x, or if we divide anything by x, as you can see in here, x in the denominator, those all functions are a polynomial function. As you can see, it's a half, so the degree would be either decimals, and then the degree in here is negative, it's square rooted, and the degree is x, which we don't know the degree, and we have in here that the number is divided by x, so that's the reason why all of those aren't polynomials. So first, let's look at this table. So if we had a function that looked like something like this, which we have the highest degree, which is 6, which is an even number, so it will be a quadratic function, which I mean by not a quadratic function, sorry. It would look like something, it would look like a parabola, and it would have, if it's, well, if A is positive, the parabola would look like this. If A is negative, it would look something like this, as you can see it in here. It's up and down, which means it goes into the negative, numbers, which is downwards. And if you would say how to write the end behavior for this, for the even degree and positive leading coefficient, so have a look at this. We know that x is going towards the positive direction, so x would be positive infinity, and if x is positive infinity, you can see that y is even positive infinity. But when x is a negative infinity, what happens to y? It goes even to a positive infinity. So that's the reason, as you can see in here, x is positive infinity, and while y goes to the positive infinity, and while x is a negative infinity, as you can see when it goes all the way to here, the y is still positive infinity, as you can see in here. But if we had an odd degree, which odd numbers like 1, 3, and so on, as you can see in here, the odd degree, which is 7, and it's a positive, so that's why it started from the positive coordinate, which is positive in here and positive in here. And so how to write an end behavior for the positive leading coefficient, and the highest degree is an odd number. So as x going to the positive direction, we can see that even y is going to a positive infinity. So that's the reason we said x to the positive infinity equals y to a positive infinity. But when x goes to a negative infinity, what happens to y? It even goes to a negative infinity. As you can see in here, y goes all the way to down. But for when we have an even degree but a negative a number, which is in here negative a, which is -2. So sorry, a is -2, which means that the function, which is the parabola in this example, it will go all the way to down. So the highest degree is 4, and I remember even in odd numbers, if I divided 4, if I divide it by 2, it will give me 2, so that's why it's even, it's not decimal number. Okay, so if it's even but it's a negative, it will go down. But how to write the end behavior? As x goes to the negative direction, so as x goes to the negative direction, y also goes to a negative direction, which is a negative infinity, negative infinity. Don't write direction. it's negative infinity. As you can see in here, x goes to a positive infinity, y goes to a negative infinity. X went to a negative infinity, y would go to a negative infinity. But when we have an odd degree, so it will always start from the negative direction. And so when when x is positive infinity, y would be a negative infinity, as you can see in here. As x is a positive infinity, y is negative infinity, and as x is a negative infinity, y would be a positive infinity. So this is what the graph says. It's really easy. So let's have a look at this question, which is y equal to x4 minus 6x minus 4. As we can see, the degree is 4, which is an even degree. We can see that the a is positive, so that's the reason you can see that the graph is open up. So it's end behavior as x goes to a positive infinity, y goes to a positive infinity, and as x goes to a negative infinity, y even goes to a positive infinity. So as you can see in this question, y equal negative 3x power 5 negative 5x squared plus 3x negative 4. You can see that the a value is a negative value, so that's the reason it starts from the negative x-axis, and you can see that the power or the degree is odd, so that's the reason the graph looks something like this. And so how to write the end behavior? So as x goes to a positive infinity, y goes to a negative infinity. Just concentrate at this part. As x goes to positive infinity, y goes to a negative infinity. But as x goes to a negative infinity, what happens to y? Y goes to a positive infinity. So this is a polynomial function, which is f of x equal negative x cube, which would be an odd graph, and it will be a negative graph. Yes, it has the odd degree and a negative leading coefficient, and the leading coefficient is negative 2. So the graph should look something like this, because it starts from the negative side and it's an odd degree, so it's an odd graph. And the end behavior, as x goes to a negative side, y goes to a positive side, and as x goes to a positive side, y goes to a negative infinity. I don't know why I keep saying side, it's infinity, I'm so sorry. And so for polynomial function, we have this function, which is y equal negative 2x to the power of 4 plus 3x squared minus 5. So I would like you to try this question. So we know that it has an even function, because you can see the degree or the leading degree or the highest degree is even, and it's a negative leading coefficient. As you can see in here, the a is negative. And to find the axis of symmetry, we have an equation that says x equal negative b divided by 2a. We have b in this question is 3, and a is negative 2, which would give you an answer of 3 over 4. So in here we are trying to graph this function. And then we would draw the table point. You can use your calculator for this, but you can draw any points, and I just put the axis of symmetry at the middle. And then using your graphing calculator or whatever you're using, you find the graph, which looks like this and says that the graph is an even graph. Just remember, when it's even, the arrows goes to the same to the same direction downwards. If it was odd, you would see in here that one arrow go to a different direction and the other go to a different direction. So you can see that I don't think you would see that in grade 10, but maybe in grade 11, you'd see, if we had this function, you'd see that even though it's a parabola, and you can see we can separate it to a different two parabolas, but the arrows still goes to the same direction. And if we, let's say we have this function, odd function, the reason is you can see that the arrow goes to two different directions. And so the end behavior would be, you can see as, sorry, let me erase this, but the end behavior, it would be as x goes to a positive infinity, what will happen to y? Y would go to a negative infinity. As x go to a negative infinity, y would also go to a negative infinity, as you can see here. And so that's all. Hope it was helpful, and thank you.